Everyone, this is Pratibha Ramkonda. So today we are going to discuss Unit 6, that is Opto Semiconductor Devices. So here we are going to cover the introduction, photodiode, phototransistor, LED, optocoupler, solar cell, laser, and the last one is maser. So before that we should know some definition such as photoemissivity. Now what is this photoemissivity? It is a process of liberation of your electrons from your metallic surface when and light is incident on that. It is known as photoemissivity, and such phenomena will occur in your vacuum and gas phototubes. The second phenomenon is photoconductivity. Now here this is a process of liberation of electron hole pair whenever your semiconductor junction is reverse biased under the influence of your light, which also varies your semiconductor's conductivity, and this process is known as photoconductivity. This will take place in photoresistor, photodiode and phototransistor. The third is photovoltaic effect. From voltaic you will get to know that this is a generation of your EMF or voltage when a semiconductor is exposed to a light energy. This is called as photovoltaic effect, and this occurs in your solar cell. So we will see one by one. The first one is photodiode. So you can see the photodiode is what? It is a two-terminal reverse biased semiconductor device in which the reverse current is proportional to the intensity of the light. So basically this photodiode consists of a photodiode and a resistor R and a DC supply. How this operation takes place? It takes place, first is whenever you are not incidenting any light on the PN junction, still a reverse current IR will be there, which will be very small, and that particular reverse current we call it as dark current. So the resistance of the photodiode with no incident light is called as dark resistance. So dark resistance can be given as dark voltage upon dark current. The second case, when you incident the light on the PN junction of the photodiode, there is a transfer of energy from the incident light on the junction. Because of this, it creates more free electrons or holes, which also increase the reverse current. The third is, now as the intensity of this light increases, your reverse current also goes on increasing until it reaches the maximum, and that particular maximum value is called as saturation current. Next is applications of photodiode. They are used for photo detection for both visible and non-visible light. It is used in demodulation, in switching applications, high-speed logic circuits, in character recognition, optical communication system. The next one is phototransistor. Phototransistor is a two-terminal, three-layer semiconductor device which is sensitive to the light energy. Like your BJT, even this is having three regions, but the base is open, in the sense there is no connections to the base region. How is the working of this? So the phototransistor is usually connected in the common emitter connection with the base open. So here the collector base junction is reverse biased and base emitter junction is forward biased. Whenever light is not incident on the junction, so there are no photo-induced carriers. Because of that, your collector current, whatever is occurring, is only due to the thermally generated minority carriers. That is nothing but it is the reverse saturation current. When light is incident on the junction, there are photo-induced carriers which will constitute photo-induced current plus the thermally generated carriers, that is your reverse saturation current. Therefore, whenever you apply the light, the total collector current will be the combination of your photo-induced carriers plus the reverse saturation current. Okay, so the next, the applications of your phototransistors are, they are used in opto-isolators, position sensing, security systems and coin counters. The next is LED. LED stands for light emitting diode. So it is a diode which will give you off visible light whenever it is forward biased. So when light emitting diode is forward biased, the electron from the n type material, they will cross across the PN junction and they will recombine with the hole which is present in your P type material. Because of this, the free electrons are present at the conduction band, and at high energy the holes will be in the valence band. Because of this, the recombination takes place, and this recombining electrons formed, they will release the energy in the form of heat and light. This is how the process of LED takes place. Next, the applications. Your LED can be used in your indicator lamps, 7-segment displays, in alphanumeric displays, IR LEDs, and in advertisement boards. They are also used in optocouplers, bar graph readers, and in optical switching. Next is optocoupler. Optocoupler is a device which will use the light to couple a signal from its input to its output. So that input will be having your photo emitter, and at the output you are connecting the photo detector. Now what happens, how this working is, when the LED is energized, your current will flow through the LED, and the light of the LED will hit the photodiode, and which will give a reverse current through this resistance which is connected here. So the output voltage will totally depend how much the large current is flowing through it. Suppose if you vary your LED, the amount of light will change, and because of this your photodiode current also change, which also your output voltage will be changed. One of the advantage of using this optocoupler is it will provide an electrical isolation between your input and output circuits, which is the only contact between your input and output circuit is your stream of light. Next is applications of optocoupler. So we have numerous applications of optocoupler, like they are used in your medical equipment applications. They are also used in the form of industrial, automotive, for data transmission, network bus isolation, for high speed data rate communication. They are also used for isolating your ground loop currents. So they are used in a high voltage, level shifting, and feedback circuits. The next one is solar cell. Now solar cell is a cell which will convert the solar energy into electrical energy. Okay, so this particular solar cell will follow the photovoltaic effect. I said you photovoltaic effect are what? They are made up of materials where sunlight will turn into your electricity. Now these PV technologies, they include solar thermal, hot water, which are renewable. These PVS cells are also composed of semiconductors, layers of semiconductors that can be silicon. Now energy will be created when your photon will strike the solar cell, and because of that, that light will be observed within the semiconductor material. Now this excites the semiconductor electrons, which will cause your electrons to flow and create a proper usable electric current. Now whatever the current is been generated, they will flow only in one direction. Because of that, we say that the current is direct current. So one PV cell will help you to provide only 1 or 2 watts, which is not enough. For that, in order to increase the power, your photovoltaic or solar cells, they are bundled over here, okay, together, which is in the form of module, and they are packaged into a frame which is known as solar panels. So these solar panels are again grouped into larger solar arrays. Fine. So this is how your solar cell works. Applications of solar cells, they are used in your satellites in order to recharge their batteries. They are also used in obtained power supply, and they can also be used in your water heater. The next is laser. Laser stands for light amplification by stimulated emission of radiation. So this particular laser is a source of your electromagnetic waves, which is at infrared and light frequencies. So they are typically, their frequency ranges from 430 to 750 terahertz. So whatever the light which is emitted from this laser is monochromatic, that is coherent. So how the basic operation consists? Okay, the laser diode will be forward biased by your external voltage source. Now whenever the electrons they move through this junction, electron hole takes place. Because of this combination, photon is released. This photon released will strike an atom, and this release the electron in turn creates the hole. Now these released electrons they will further again combine with the holes, right? Now it means that whenever your forward current increase, your large number of charge carriers will, whenever you are increasing your forward current, your large number of charge carriers they will enter the depletion. Because of that they will excite the atom, and these atoms they will go and strike. Now the atoms at the first they will emit the photon of the energy. So it is not that there is only one atom, there are several photons, right? So they will all strike their reflective ends, and they will create a back forth reflections to the either ends. So because of this activity of reflecting and generating of will increase your number of photons, which in turn increase the initial reflected photons of your light. Because of this you will get a coherent beam. Okay, this particular beam is known as laser beam. Next is applications of laser. So these lasers are used in welding, communication, measurement of distance. You can also use it for direct tunnel drilling, to eradicate, even this is used for the eradication of your cancer growth, and direct military weapons in tracking of aircrafts, that is also used for CD or write. Next is maser. So this maser is standing for microwave amplification by stimulated emission of radiation, right? So now the applications here, what happens is the electrons which are in the lower energy they will jump to higher energy level. So this excitation is nothing but it is subjected to stimulation with the help of another input signal which is having same frequency. Because of this the emitted radiation will be having greater energy, right, which will result in the desired frequency of which you want. So thus your amplification will be done at your microwave frequency. Because of that we call it as microwave amplification by stimulated emission of radiation. So they have applications in your radio telescope receivers for your communications, and it is also used where your lowest possible noise is a prime importance. Thank you, students.